afternoon. If you can hear me and you can see my slide, can you please raise your hand? Okay, thank you. All right, thank you, thank you. Siapa yang sudah balik campus? Anyone have returned to campus? Ada yang sudah balik di campus? Masih lagi di kampung kah kamu ini?
Ya, masih lagi.
Alright, so karena masih lagi di kampung, hari ini kita buat secara online lagi. Oke, hari ini kita buat secara online lagi. So, for today, what I'm going to explain to you is basically some of the procedure that you are going to cover. Okay, you are going to cover in the during the project. Yeah, so some of the lab procedure or lab experiment that you are going to cover during the project. All right. So in the project, you can see that there is one table. You can see that there is one table, and in the table, the requirement, yeah, the requirement for soil that you need to use for the backfilling are listed in table 1. So whatever site you choose, you have to conduct the test to assess whether the soil meet the requirement or not. Okay, sama ada meeting the requirement ataupun tidak tu, it will not affect your marks lah. Okay, so sama ada dia memenuhi kriteria dalam list ini ataupun tidak mempengaruhi markah kamu. Your mark is determined based on the result from your experiment. Okay, whether your findings meet the requirement or not will not affect your marks. Yeah. Therefore, your marks comes simply from how you conduct the test, how you analyze the data, how you interpret the data, and how you write your report. So that is how your marks tabulated. Yeah. So based on the requirement, you can see that there are 11 major requirements. Yeah, 11 major requirements. The first one is site distance. The first one is site distance. So when you are proposing your site location, the requirement is that it should be less than 5 kilometers from the project site. Yeah, the project site is located at Teluk Likas, near Likas, Likas roundabout, opposite the Bandaraya Mosque. And when you set for your location, there must be it must be less than 5 kilometers. So how do you do this? Of course, by obtaining the distance or measuring the distance, which you can do from the Google Earth. Yeah. So most of the groups, so far 7 groups have submitted their location. So far 7 groups have submitted your locations. So all 7 groups have submitted correct locations and meeting the requirement number 1. Okay. Requirement number 2 is based on soil classification, USCS. So for this requirement, you have to conduct tests in order to meet the requirement of GW, GP, GM, GC, or SW, SP, SM, SC. And the tests required are sieve analysis and Etterbeck limit. Yeah, this is the same experiment for ASHTO. ASHTO is requirement number 3. F27 or stronger. For this test, or this requirement, you have to conduct sieve analysis and Atterberg limit. Okay. Next one is natural moisture content. It should be less than 85%. And in order for you to get the natural moisture content, you have to conduct the lab moisture test lah, where you have to put your soil sample in oven. Yeah. Next is natural moisture content. Natural moisture content, pH, it's supposed to be between 4.0 and 8.5. Yeah, 4.0 and 8.5. Specific gravity higher than 2.60. Organic content or loss of ignition, either one, must be less than 15%. Compaction should achieve maximum dry density of 1,800 kilogram per cubic meter, and optimum water content between 0 to 25, 8 to 25. Permeability higher than 1 times 10 power of minus 4 meter per second. Shear strength, cohesion larger than 0.5 kPa, and frictions of larger than 5 degree, and consolidations of larger than 1.0 times 10 minus 4 cm square per second. These are the requirements. So there are small notes under the table. Please note that for sieve analysis, hydrometer must be conducted. For Atterberg limit, LL and PL test must be conducted. Yeah. For permeability, you have to choose either one. Constant head permeability test or falling head permeabilities. Either one. Yeah. So depends on the type of soil that you have. If the soil is coarse grain soil from your sieve analysis, your permeability is constant head. If the soil is fine grain soil from your sieve analysis, the permeability test that you have to conduct is what? Falling head test. Okay, remember. For shear strength, you have to choose either triaxial or direct shear. For triaxial, this is more suitable for fine grain soil. Direct shear box, this is more suitable for coarse grain soil. Again, the result should be obtained from sieve analysis. Yeah. And lastly, for consolidation test, the test is on using 1D consolidation, using 1D consolidation test. Okay. So these are the requirements for your project. Yeah. All right. All of the lab manual, as I mentioned last week, yeah, as I mentioned last week, your lab manual, they must be obtained from, so you can use the lab manual, the one that we shared on ITEL. So this is the lab manual that I have prepared. I type and I edit and I put all of the nice photo, nice figure, nice table. Just make sure you use them, and then if there is any confusion, you can come and see me. Yeah. So this lab manual, in ITEL. Yeah. So you can get them in ITEL. All right. So first thing first. First thing first. Once you have obtained your location, what you have to do first is collecting soil sample. Okay, collecting soil sample. In order for you to collect sample, you have to dig. Usually, You are digging, either you're using your hand, either you're using backhoe, or either you're using excavator. If you're digging below 2 meters, sufficient to use your hand. Okay, you can use your hand below 2 meters. If the depth required is between 2 to 4 meters, you have to use backhoe, wheel backhoe. Larger or higher than 4 meters, you have to use excavator. For this project, sufficient to use your hand because you need soil collected below 2 meters. Yeah, below 2 meters. Okay. So the soil that you collect for this project is disturbed soil sample. Disturbed soil sample. Okay. For tests such as consolidation and shear strength, we are going to remold the soil sample. We're going to remold the soil sample so that you can get the strength. Yeah. But for the other tests, you have to use disturbed soil sample. Yeah. Disturbed soil sample. Okay. So the first test you have to do is sieve analysis. Okay. The first test you have to do is sieve analysis. Do you remember what is the amount of soil needed for sieve analysis? Usually around 1 kg to 1.5 kg. Yeah, around 1 kg to 1.5 kg. Around 1 kg to 1.5 kg. So for sieve analysis, yeah, they are required for soil classification. So soil classification required sieve analysis and plasticity. So in sieve analysis, you have to use the sieves, yeah, in suitable size. Okay, I'm sure you have done this test last semester. So I'm sure you know how to clean them, how to arrange them in order, and how to get the initial weight. Initial weight before you conduct the test. Yeah, before you conduct the test. Okay. Then after that, you get the table ready. Make sure your table is ready like this. Yeah. The table is prepared in order for you to record your reading. In order for you to record your reading. So before anything, before everything started, you get the weight of the sieve. Okay. And then you get the weight of the soil that you are going to test. After you get the amount of soil, you place the sieve, the soil on the top of the sieve, and then you shake them. Don't shake too long, yeah? Otherwise, the machine will get too hot. If it's too hot, the machine will automatically stop. All right? So after 1 or 2 minutes, you stop the test, and then you continue on. Yeah, remember, don't run the test continuously for too long. If you run the test for too long, the equipment will get overheated. When the sieve analysis equipment gets overheated, it will stop automatically. All right, and it will disturb your flow. Therefore, in order to do the test, stop after every 1 or 2 minutes. Okay, to cool down the equipment. Then you continuing on. Yeah. After 10 minutes, you can remove your sieve and then you can get the wet. Yeah. You can remove the sieve, then you can get the wet and you can do the calculation like this. Yeah. You can calculate the weight of soil retained, the percentage of soil retained, the cumulative return, and the percentage of finer. Then lastly, you can plot your graph. Yeah, graph like this. Yeah, you can plot your graph like this. And from the graph, you can determine whether what is the domain percentage in the soil. Is it gravel? Is it sand? Is it silt? Or is it clay? What is the domain percentage for every type of soil? What is the amount of soil, yeah, in percentage? You can get from the sieve or you can get from the curve, yeah? You can also determine whether the soil is poorly graded or well graded, yeah? There is a formula for coefficients of curvature and coefficients of uniformity. Okay, so after that you can determine based on your analysis. Yeah, all right. After sieve analysis, your next experiment is Atterberg limit. For Atterberg limit, not all of the soil are suitable. Only the soil passing sieve number 40. Okay, only the soil passing sieve number 40 can be used for Atterberg limit. Remember, not all of the soil. So after you sieve, collect the soil from the bottom 10 and from the sieve number 40 downwards. Yeah, from the sieve number 40 downwards. These are the samples that you use for Atterberg limit. Okay. Then you have to conduct the two important tests. First one is liquid limit. Yeah. First one is liquid limit test. Okay. For liquid limit test, either you choose Casagrande method or you choose penetrometer, cone penetrometer method. Both method can be used. Yeah, both method can be used. And in this both method, you have to plot the graph to determine the LL. Yeah, this is the graph for your liquid limit. This one is using Casagrande. You can see that the number of blows equivalent to 25 that intersect with your straight line, yeah, your graph from straight line, the liquid limit is, the value is equivalent to the liquid limit, yeah? So plot the straight line from your data, yeah? And then from number of blows, 25, this is using scale, yeah? Log scale, yeah? You can obtain the liquid limit by interpolations or cross section. Yeah. So number, like in this example, the liquid limit is 42%. Yeah, 42%. So that is how do you get liquid limit from your Atterberg limit plotting. Yeah. Similarly, if you plot using Atterberg limit or penetrometer, your graph will look like the one on the right side. You get straight line as well. But for this method, your penetrometer is, your graph is plotted on arithmetic scale or normal scale. Yeah, normal scale, not semi-log like Casagrande. Yeah, not semi-log, but arithmetic or normal scale. So in this case, you can see that the penetration equivalent to 20 millimeter will give you the value for liquid limit. Yeah, will give you the value for liquid limit. So again, two different method, two different scale of graph, and two different way to get the liquid limit. One is equivalent to 25 blows. Another one is equivalent to penetration 20 millimeter. Yeah. So you, for this method, you choose one. You choose either one. Okay, you choose either one, either Casagrande or cone penetrometer. Yeah, this is for liquid limit. Lastly, for Etterberg limit, you can choose. You have to conduct the plastic limit test. Yeah, plastic limit test. In this plastic limit test, you roll an amount of soil wet from the liquid limit, an amount of soil wet from the liquid limit, you roll on the surface of the glass in our lab. The purpose is to ensure that the glass is absorbing the moisture, and therefore, once the moisture is absorbed, the soil will change from liquid into plastic, and therefore the moisture content at diameter 3 millimeter, and the soil start to crumble. Look at the photo here. Yeah, you roll with the palm of your hand to reduce the moisture. After it reach the plastic limit, you can see that it will start to break down or to crumble. So you can stop the test and you can get the moisture. The moisture is equivalent to the plastic limit. Yeah, the moisture is equivalent to the plastic limit. If you want to get accurate result, what you have to do is repeat the test to get the average. Yeah, 2 or 3 times to get the average. So that is the value of your liquid limit or plastic limit. Yeah. Now, therefore, once you have plotted your Casagrande, once you have plotted your what you call it, cone penetration, and once you have obtained your plastic limit, you can use the plasticity chart here above here to obtain what is the dome in the fine grained soil, whether is it clay or silt. If it is above, then it is clay. If it is below, then it is silt. Okay, so this is the sample of data. Yeah, this is sample of data that can be used to plot. Yeah, for liquid limit, you plot on graph. For plastic limit, what you have to do is you get the average value. Yeah, you get your average value. After you get the average, that is the value of your liquid limit. Yeah, okay. Are we clear so far? Okay, all right. Okay, good, good. Okay, if you're clear, good. I move to the next test. Then you have to conduct those soil classification. Oh, wrong spelling. Soil classification systems. Okay. For this test, you have to classify using 2 methods only. Okay. 2 methods, which are the USCS and ASTM. Which are the USTM or USCS. Yeah. So for USCS, the table is shown on the left side. For ASTM, the table is on the middle one. Okay. There are several other methods such as USDA, British Standard, or ASTM Standard, but we are going to focus on these 2 classifications because these 2 classifications are the one mentioned in the requirement. Yeah, the one mentioned in the project requirement. So we focus on this. Okay. Now, next one, what happened? What is the test you have to do? Next is moisture content of the soil. The natural moisture content and the moisture content of the soil. Yeah. When you are collecting your soil sample, if you want to get the natural moisture content, make sure that the soil sample is wrapped in vacuum container. Yeah. Wrapped in vacuum container so that the moisture content will not evaporate. Yeah. Usually in tight container. Yeah. So after you get the soil sample, what you have to do is measuring the weight of the soil in original condition. Yeah. Get empty container. Get empty container and measure the weight of the empty container. After that, you put your soil sample in the container, and then you place the container with the soil sample in the oven. But before you put in the oven, of course, you get the weight of the soil and the in the container first. Yeah. And then you put in the oven. Yeah. For how long? Usually 24 hours. Usually you put the soil container in the oven for 24 hours and you set the temperature of the oven for 105 to 100 Celsius, degrees Celsius. Yeah. Then after 24 hours, you get the weight of the soil in dry condition. Now you have three weight. Yeah. Weight of the soil, weight of the soil, empty container, weight of the empty container, weight of the container and the wet soil, and then weight of the container and the dry soil. So based on this weight, you can calculate the water content, which is equivalent to weight of the soil, uh, wet minus dry, divide by dry. Wet minus dry, divide by dry. Remember, that is the formula. Yeah, wet of the dry, divide by dry. All right. Next is specific gravity. Okay. For this project, you are required to get specific gravity. The requirement is specific gravity. The requirement is specific gravity larger than 2.6. Larger than 2.6, yeah? So specific gravity is the ratio between the density of the soil grain to the density of the water having the same volume, yeah? So the process to get specific gravity is simple. You use specific gravity bottle model method or cyanometer jar bottle method. Both of these method available in our lab. Yeah, in our lab. So make sure you clean them first. Yeah, and the process is very easy. Yeah, you follow the instructions on this table. First, get the temperature of the water, and then set or get the weight of the specific gravity bottle that you're using. What is the weight? And then the dry soil you put back into the soil, into the specific gravity soil, specific gravity bottle. Get another weight, then add water. This is the tricky part. Yeah, before you add water, when you add water, do not add full to the brim. First, add a little bit, only about 3/3, and then you shake the bottle. The purpose for you to shake is to ensure that the soil is thoroughly wet and uniformly uh, filled with water. Okay? After you shake them, you remove the bubbles, you add water, and then remove the bubbles again. Then you get the weight of the soil and water. Yeah? This is for weight number 3. After that, you clean the bottle. You remove the soil and the water. You clean the bottle. Fill with water again. This is weight number 4. So you have weight number 1, which is the weight of the bottle empty. Weight number 2, which is the weight of the bottle and dry soil. Weight number 3, which is the weight of the bottle and the dry soil, now wet, and the water. This is the tricky part. Okay, add water little by little, shake and then full. Then clean everything only for the bottle and water. This is weight number 4. So you can calculate the specific gravity using this method. Yeah, using this method. All right. Now pH. Okay. Why it is important to determine the pH? Why it is important to get the determine the pH? The reason being, for some material, maybe they are reactive to acidity or alkalinity of your soil. Yeah, maybe they are reactive with the alkalinity or basalty of your soil. Therefore, this is necessary. So you have to conduct the test. Yeah. So if you are using soil, very easy, simple. What you have to do is you add 20 gram of soil sample into 100 ml of your water. The water that you use is distilled water. Okay, the water that you use is distilled water. If there is no distilled water in geotech lab, I want you to collect distilled water from environmental lab. Okay, I repeat, for pH test, you have to use distilled water. If there is no distilled water from geotech lab, you need to get distilled water from environmental lab, our environmental lab. Okay, Miss Dayang. Okay, all right. So very easy. You add water with soil. You add water with soil and then get the pH. Yeah, that's all. All right. So do not follow the table here. This one is if you are using stabilizer. The table here is if you are using stabilizer to improve the soil. In your case, you are not using stabilizer, so only add 100 meter, only follow step number 1 and step number 2. I repeat, only follow step number 1 and step number 2. Step number 1 is prepare water 100 ml in beaker. Step number 2 is add soil 20 gram and check the pH. Check the pH before you add and after you add. Yeah? Okay. Now, loss of ignition. Loss of ignition. What is loss of ignition? Yeah. Loss of ignition basically measuring the humus content or organic soil. Although both organic and ignitions slightly different, but the purpose is the same. We want to know the amount of impurities in soil. Yeah, impurities in soil. Okay, we want to know the amount of organic content or volatile matter in the soil sample. Down, vegetative measures. This is what we have to obtain. So the method is very easy. You have to dry your soil sample first in oven with low temperature, then in furnace with high temperature. So you can see that there is a difference in your soil sample before and after. So you get the calculate the loss of ignition from this sample. Basically, you determine the difference in weight, the difference in weight of the soil. Yeah. So you can calculate the loss of ignition using the formula here, which is the weight of your soil sample before and after you dry them in in oven and in furnace. Apa beza furnace and oven? Oven means that you have to wet your soil sample in temperature less than let's say less than 400 degree. If you want to use more than 400 degree, you use the furnace. The furnace that you use is located at concrete lab. I repeat, the furnace for loss of ignition test is located at concrete lab. Concrete lab, yeah? Concrete lab. All right. Okay. So now, after you obtain, you can report the percentage of loss. In your PBL, the requirement is must be less than 15%. Yeah? Must be less than 15%. Okay. Next is consolidation test. For the consolidation test, usually the experiment will be conducted for 7 days. 7 days, yeah? But for your project, remember, for your project, I want you to conduct the test only for 1 day, only for 1 kg of weight. I repeat, for your test, only for 1 day consolidation, and only for 1 kg, 1 kilogram of loading. 1 kilogram of loading. I repeat, yeah? Not 7 days, only for 1 kg of loading, yeah? Okay. For this test, you have to use the dial, you have to use the setup shown here. Yeah? You have to use the setup shown here. First, you have to prepare the soil sample. You have to prepare the soil sample. How do you prepare the soil sample? The soil must be compacted using Proctor, and then you transfer the soil into the dial, into your specimen ring. Okay, you transfer your soil sample into the specimen ring. How do you transfer your soil sample into the specimen ring? You take this specimen ring and then you push into your soil sample, and then you dig the surrounding of the soil sample, and then you extract the specimen ring. Yeah, I repeat, you take the specimen ring from your consolidation cell and then push it onto the surface of your compacted soil, and then dig the surrounding area, and then you can remove your soil sample. This is your soil sample for consolidation. Yeah, soil sample for consolidation. Okay, so remember here, if you look at the photo here, yeah, this is the soil sample. This is the soil sample. The soil sample is collected from the compaction. After you compact the soil sample, you push the ring into the surface, and then you pull it back, or you dig the surrounding, so you have the soil sample. And then you place the soil sample here. Okay, lever arm. You can see the lever arm ratio here, 1 to 10, and then you can get the loading 1 kg. Then you take the readings. Yeah, you take the readings. Okay, so this is the procedure. Yeah, after you put the soil sample, okay, you set the dial gauge on the top of the loading bar. You set the dial gauge on the top of the loading bar. Set the dial gauge readings to 0. Set the dial gauge reading to 0. Okay, after that, you put your water inside the soil sample. So your soil sample will be submerged in water. Your soil sample will be submerged in water. After that, you put the loading. When you put the loading, the dial gauge will start moving. When you put the loading, the dial gauge will start moving. So you take the readings for 24 hours. You take the readings for 24 hours, the reading of the dial gauge. And if you plot the reading, you can get CV. You are not going to get void ratio or loading. You can get CV value. But void ratio and the loading can be calculated. Yeah? Can be calculated. So, this is the readings that you will get. I think we already learned in class in Geotech 2 how you can plot the data, either Casagrande or Taylor method. Yeah, we already learned in Geotech 2 how do you plot the data from the consolidation test to graph. Either you can plot using Casagrande or you can plot the data using square root method or Taylor method. Both graph will give you the value of CV. Yeah. So this is Casagrande. Yeah. This is Casagrande. You can get the value of CV from the equation. And another one is Taylor, is not shown here. Yeah. So it's up to you to choose whichever is most suitable to you. Yeah. All right. Next is compaction. Next is compaction. For the compaction, also you have done the test in I think PBL last sem. So this one is very easy for you. The requirement is to make sure that the maximum dry density is 1,800 and water content between 1 to 15. Yeah. So for this test, you compact the soil sample in 3 layers. Yeah. You compact the soil sample in 3 layers. After you add water to it. Yeah. And after you compact the soil in 3 layers, you get the readings, the weight of the compacted soil. Can I give you warning? Can I give you warning? The first water that you can use is between 50 to 100. And every time you add only 50. Add 50, 50, 50. Okay? The first one, 50 to 100. Either you choose 50 to 100 because you don't want it to become too wet. If your soil is a little bit wet, add only 50. If your soil is very, very dry, 100. This is the first water content. The second water content, moisture content, add 50 ml only. Don't add 100. Don't follow the instructions online. Okay? Add only 50. So the third times, add another 50. Fourth times, another 50. You add 50, 50, 50 only. Do you understand this? Okay. What happened if you add 100? You will get void. You will get graph that increasing. Okay. This is after you analyze. If you add too much water, what will happen? If you add too much water, what will happen? Your graph will look like this. It is dropping, 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 and dropping because you had too much water. Okay, but if you add just a little bit of water, your graph will increase, 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 and then decrease, 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 decrease. Okay, your graph will look nice and more accurate. Okay, if you add too much water, it will decrease right away. So how do you know whether too much or not? Add only 50. Don't add 100. All right. The reason why I keep repeating this information, because last year during your PBL, I repeat 10 times. Don't add 10, don't add 10, don't add 10, don't add 10. Add 50. But some of you add 10. So you get result like this one, the one on the left side. Okay. All right. So next. Okay. So after that, after the compaction, where we are. After the compaction, then you have to do permeability. Permeability. Okay. Permeability. For permeability, you have to choose either falling head or constant head. One is for the fine grain soil, which is falling head. Another one is for the coarse grain, which is the constant head permeability test. Yeah. So this is how the setup look like. The one on the left is constant head. The one on the right is falling head. Yeah. The one on the left is constant head. The one on the right is falling head. So you put your cell sample inside the mold, the glass mold here. Okay, the glass mold here. And then you follow the instruction. You can see if you follow the instructions, you can take the readings of the height of the water. Yeah. The height of the water, yeah, is measured. So this is how it look like. You measure the height of the water, and then you collect the amount of water. Okay, when you open your tap, your water tap, you can see that the water will fill the cell sample in and then flow out. Then you can see that you can collect the amount of water. So you take all of the readings, and then you can collect, you can find the probability value, which is K. Yeah, which is K. Similarly, for falling head, you take the readings of the height of the water when you open the channel. When you open the channel, water will flow into the cell sample and the height of the water will decrease. So you measure the height of the water. Yeah? You measure the height of the water. So the readings from the height of the water is used to calculate the value of permeability K. So K is the permeability. Yeah? So you can see that falling head, you have different formula of permeability. For constant head, you have different probability of permeability. Yeah. So you can calculate the value of the probability for both. Okay. So this is the probability test. All right. You can see that some of the tests you have done in your PBL, some of the tests you have not done yet. Ya, consolidation you have not done yet kan? Belum lagi kan? You have not done yet. Probability you have not done yet. Yeah. For this test, I will repeat the what you call it demonstration in the lab. I will repeat the demonstration in the lab because you haven't done the test yet. Yeah. But for the other tests like sieving, compaction, specific gravity, these are the tests that you have done before. So I will not repeat the demo. Yeah. I will repeat only the one that you have not done yet, which are the consolidation and the permeability. All right. Okay. Lastly, shear strength test. So there are two shear strength tests. One is for direct shear box, yeah, which we have done. And these are the data that you obtained from direct shear box. Yeah. Another one important. Okay, I want to mention this important. This one is important. I want you to pay attention. Okay, I want you to pay attention. Okay, pay attention to the calculation of normal stress. Okay, calculation of normal stress. The normal stress is based on the loading 1 kg. However, when we convert 1 kg into normal stress, we have to remember the mechanism, loading mechanism. Our loading mechanism, the ratio is 1 to 9. 1 to 9, meaning that if you put 1 kg loading on the hanger here, the loading that's supported by the soil is 9 times 1 kg. 9 kali ganda. 9 times of 1 kg. Therefore, when you're calculating the normal stress, you must amplify 9 times. Times 9. Darab 9 kali. Example. Yeah, remember, our equipment has an amplification mechanism of 1 to 9. This one you missed last time, yeah? For loading 1 kg and 0.5 kg hanger and sample box 60 millimeter, the calculation of normal stress as follows. Yeah. First, what is the total load? Yeah. What is the total load? Total load is dead load 1 kg times 9. Darab 9. Why darab 9? Why times 9? Because of the loading mechanism, lever arm mechanism. 1 to 9. Yeah. So total load is dead load darab times 9 plus the lever, the weight of the lever, which is 0.5. Sorry. Let me do correction here. Let me do correction here. Yeah. This is times. Okay, not plus. Okay. Okay, here, correct. Dead load 1 kg times 9. Because mechanism is lever arm mechanism is 1 to 9. Okay. Plus 0.5 of the weight of the hanger. Weight of the hanger, 0.5 kg. So the total load, if you add 1 kg, is 9.5 kg. And the total force is 9 kg, 9.5 kg times gravity, 9.81. So 93. Sorry, this one is kilonewton ini. This one is Newton. Yeah. This one is not kilonewton, Newton. Yeah. This one is Newton. Okay. All right, Newton. So after that, kilogram to gravity change into Newton. After you get Newton, you determine the normal stress, which is Newton divided by the area. So this Newton divided by the area, you get 25,000 Pascal or 25 kilopascal. Yeah. So make sure you convert the weight of the normal weight by multiplying with the lever arms times 9. Yeah. All right. Another readings that you have to take is from the direction box proving ring. Here, proving ring. Remember, one cycle outside, outer 100 unit, inner is 1 unit. So satu kali pusing, one cycle outside equivalent to 1 on the inner side. If pusingan, if there are 2 times of outer, mean that 200. So inside will get 2 reading. Okay, so if the outside is if the inside is 3, outside is 50, meaning that you have inner multiply with 100 times plus the outer. Yeah. So I repeat. Let's say your inside is, let's say your inside is 100. Okay. Let's say your inside is 100. Inside is 100. 1. Tapi outside is 25. So your total is 125. Because inner, the scale at the in here is one cycle of the outside 100. So 100 is one outside. Okay. If the in is 2 and out is 35, so your reading is 235. Okay, so that is how do you get the readings from the dial gauge. So after you get the dial gauge, multiply with reading with the dial gauge using the factor. This is the factor, proving ring factor. Okay, the proving ring factor, we have 3. Depends on the scale here that is shown on the equipment. So get the number on the equipment so that you get the calibration factor. Okay. If you are using number 1 and your reading is 210, you multiply with calibration on 21. So this is 0.00261. Your value is 0.5523 kilonewton, because the unit of the calibration is kilonewton per division, and your reading here is division. Okay, your reading is division. So you multiply the readings 210 division with the calibration factor, you get 0.5523 kilonewton, because the calibration factor is 0.00263 kilonewton per division. Yeah. So what happened after you get the readings into kilonewton? You convert into shear stress by dividing with the area. So if you divide 0.5523 kilonewton with the area, you get 0.0001534 kilonewton per millimeter square, or 153 kilopascal. Yeah. Therefore, you can plot your semi-log with your, you can plot your normal tadi, and then you can plot your shear. Okay. 1 point, 2 point, 3 point. Yeah. And then you can plot your straight line. Yeah. You repeat the test 3 times. Yeah. Okay. This is the direct shear box test. Yeah. This is the direct shear box test that you can use for coarse grain soil. Okay. The next one is shear strength using triaxial. So the same method apply. Yeah. Your soil sample, you put inside your membrane. Okay. Your membrane. Then what you have to do is that you increase the cell pressure. Okay. You increase the cell pressure until the sample fell. Until the sample fell, there is a crack in the soil sample. It crush. Yeah. It crush. It crack into 2. So you get the readings from the cell pressure, you get the reading from the deviator pore pressure, and you get the reading from the deviator stress. So this one will give you minor and major stress. Yeah, minor and major. So this one is the minor. Before you start the experiment, This one is the measure after the sample fell. So you repeat the test 3 times. So you can plot your Mohr circle to get your cohesion and angle of friction. Yeah, angle of friction. So this is method using triaxial test. Yeah, method using triaxial test. So all in all, yeah, I have explained all of the tests here. Yeah, I have explained the sieving and Atterberg, moisture, pH, specific gravity, LOI, Proctor, permeability, shear box, and consolidation. So after that, you can conduct your lab test. All of the detailed explanation, basically, I've already explained. My explanation is based on the manual. Remember, for this lab, geotech lab, 1 credit hours, there will be a final test, individual test. And in the individual test, procedure is one of the important thing. Procedure is one of the important thing in the individual test. Therefore, you have to read and understand the procedure. Make sure you read the manual. Yeah, make sure you read the manual. All right. That is all for today. My briefing for today, or my